Solving exponential equations. The basic idea that I want to do when I solve exponential equations is I want same base exponential expressions, both sides of the equal sign. I'm trying to get, say for instance, 3 and 3 to the power of something and something, where the first exponent will be an equation or an expression containing x, and the other expression will be will only contain numbers, and then from there on I just put these two exponents equal to one another. Say for instance I have x plus 2 there and 4 there, then I will have that x plus 2 is equal to 4, and then I can solve a basic linear equation from there. So what I will do, if I have for instance different bases, say for instance this is now easy example just to get the idea across, is say for instance I have different bases. You know hopefully that 9 is 3 squared, but you can use this shift fact function to write equations in, or express or numbers in their exponential form. So I put 9 is equal to first, so that I have the 9 there on the calculator. Let me just zoom in for you a little bit so you can see. And then I press shift fact on the Casio calculator. If you don't have this Casio calculator, unfortunately the other models can't do this, write it in exponential form, then you'll have to go do the prime factor form, which is that ladder dividing by prime numbers to get 9 is equal to 3 squared. 9 is now very straightforward, but sometimes we will have difficult numbers that's not as straightforward. And then what I want to do is get this the same basis, so that I have two expressions there when I can make equal to one another as a linear equation, and then solve the linear equation. So that's the basic procedure or approach I will take for most exponential equations. So let's look at a few examples of what they can ask you. Say for instance I have 3 to the power of x minus 2, and again I'm going to start with easier problems and then go a bit more difficult as we move along. I want to write this in exponential form. Now I know 81 is 3 to the power of 4, but if you don't know that, you can either do the prime factor form or use your calculator shift fact. Just make sure to press equal before you press shift fact, otherwise it won't work. And then I can say that the two exponents must be the same, and I have that x is 6. Okay, sometimes they give you a fraction on the one side that looks like this, and there you're going to use the rule that 1 over a to the power of x is a to the power of minus x. So I'm going to do that here. I know that 16 is 1 over 2 to the power of 4, and then I can write 1 over 2 to the power of 4 as 2 to the power of minus 4, and then I know that x plus 2 must be equal to minus 4, so x is equal to minus 6 if I take the 2 over there, over the equal sign. So these are easy ones, but you see how I use the basic approach of just trying to get the same basis, one expression with the same basis on each side. Say for instance I have now this. I'm trying to get one expression on each side. So this here is a bit of a problem for me because I want one expression. Now I can take it over, but is that going to make it one expression? Yes, because I can add the numbers. I can't add the power exponent with a number, so I must take the 3 over so that I have 3 to the power of x minus 1, and 24 plus 3 is 27. Now I have one expression on each side with a power exponent on this side, and I want to rewrite 27 as 3 to the power of 3, again prime factor form. And then I can say that x minus 1 should be 3, so x is 4. What happens if in the previous case I just have a number, so the number I can take over and add on that side, but what happens if I don't have a number, if I have two powers, and I want to sort of write one expression on each side, so these two exponent forms creates a bit of a challenge for me. Now remember this rule that says that a to the power of x times a to the power of y is equal to a to the power of x plus y, exponential rules. If I have two things added, I can separate them as a product with the separate exponents, and I'm just going to use this rule that side to that side backwards with this one. So I'm going to write this as a 5 to the power of x times a 5 to the power of minus 1. Can you see what I did? And then I have this, and now I can take the 5 to the power of x out as a common factor. This taking out a common factor with exponents is something that you'll see quite often actually. So remember this example and this hack that I'm doing here, because we are going to use it quite a lot, and you are going to see it quite a lot, especially for grade 11 and 12 maths. So now I can take this and divide 30 by this on the other side, which is 1 1/5, or 6 over 5. So I can divide by 6 over 5, or multiply it by 5 over 6 on the other side, and 30 divided by 6 is 5 times 5 is 25. But if you don't follow my train of thought how I got from 30 to 25, really don't panic about that. All you can really do is take 30 over, and you put in this bracket 5 to the power of minus 1 plus 1 plus 1. So I just take this bracket over 30, and then if I press equal, it gives me 25. Right, so can you see I just added in my calculator 30 divided by this bracket as it is, and I get 25. So 5 to the power of x is equal to 5 to the power of 2, and that means that x is 2. So then the last step is not ridiculously difficult. But remember this method of factorization, where I can break up an exponent with an expression into this, so that I have a product of separate terms that I can actually take out a common factor. These questions comes out of past papers, so it is something that might be worth just having a look at this, because this is actual past exam paper questions from previous years that looks like this. Okay, so I want to have one expression on each side, and I want to have similar bases. Now I have a 12, a 8 and a 36, so that is really disturbing to me actually. So I'm going to write 12 as 2 squared times 3 to the power of 2x, and I write 8 as 2 to the power of 3, and I write 36. I'm not sure of that one. It's supposed to be 2 squared, 3 squared actually. You will see as you use this quite a lot that the prime factor form, you'll get the hang of a few of them, which is always almost the same. But I can quickly show you that 12 breaks down into shift fact, breakdowns into 2 squared 3, which is what I have there, and 36, first press equal, shift fact breaks down into 2 squared 3 squared. So there's that. And now this is 2 to the power of 4x. Remember your exponential rules. If you're not quite comfortable with that, we will come to that in the next example. In the next chapter we'll come to exponential rules, so don't worry too much about it. And we'll also do a few solving of exponential equations also in that chapter. Minus 2 to the power of 2x times 3 to the power of 2x. And now I can oh, I wrote the question wrong. Something seemed funny to me here now. This was not a minus, it's a product. Okay, that makes it a lot easier actually. Okay, so now I have 2 to the power of 4x times 3 to the power of 2x, and I have 2 to the power of 2x plus 3. I can just add these two. And then times 3 to the power of 2x. Now can you see I can divide both sides by 3 to the power of 2x and then get rid of those two terms, and I just have one expression on each side. 2 to the power of 4x, 2 to the power of 2x plus 3, and this then gives me that 4x is equal to 2x plus 3. So I take the 2x over 4x minus 2x is just 2x is equal to 3. So x should then be equal to 3 over 2, or 1.5, or 1,5. All of these answers equally alike acceptable. All right. Okay, let's look at another example. I think this might be number 5, not number 6. So I have x to the power of 1 over 3. Now I have a fraction in the exponent is equal to 4. This is not technically an exponential equation because my x is not in the exponent. It's on the ground, but just to show you how to treat this if you have funny exponents, you know this rule that says a to the power of b to the power of c is equal to a to the power of b times c, or bc. If I have two exponents over one another, I can multiply them. Now I can use this concept by thinking if I multiply a third with 3, it becomes 1. So then I can easily get rid of this fraction by just getting the third power both sides, because it's an equation. and then I'm rid of this third, and I have 4 to the power of 3 is 4 times 4 is 16 times 4 is 64. Right, 4 to the power of 3 is 64. So this is just something else to also keep in mind when you work with exponents that or fractions that you don't like. You can also use this concept. Remember this trick that I did here.